Hello everyone. This is final year project developed in partial fulfillment of work done for the academic year 2020 under guide Dr. C.H. Vithalani, Head of Electronics and Communication Department, Government Engineering College Rajkot. Optical Character Recognizer or OCR is developed keeping in mind the excessive developments in character recognition at high level, making it an easily available on platforms like websites or specially dedicated applications. The concept behind OCR is to make character recognition facility as inbuilt functionality for a camera module. That is, if you open your mobile camera as easily, you are able to crop a captured image, change its contrast, and control the blurring and clarity at pixel level. You will be able to read characters in the image with same level of ease. Thus we aimed at implementing the optical character recognition at hardware level. The contents of this video include to visit particular section. Timestamp is available in the video description. The main crux of the project are three necessary processes. The flowchart for the same as you can see. First, a color image captured from the camera module or the pre-stored version of the image is converted to grayscale levels by using a black and white conversion method. Then this grayscale level image underwent thresholding such that pixels having value less than 0.44 in our case is removed. More often such pixels are redundant and have no major effects on the image, but our data to be processed is reduced and image artifacts such as dots and graininess is reduced. Third process is our image is compared with the character set pre-stored in our database. These kind of datasets are easily available online for various fonts and styles. We chose standard Arial at first for the MATLAB simulation. Then using Tesseract the character recognition is on word level. It's time for main modeled functionality which we are proposing in a camera. So here's the MATLAB simulation for the same. For your reference, the MATLAB code is linked in the description box. We have major 5-feature camera. It has histogram in which you can analyze which intensity levels are prominent in the image. RGB gray, it is a built-in MATLAB function which converts the color image to black and white. Rotate clockwise and rotate anti-clockwise, which is akin to 180-degree change in angle. Invert image, in cases where our major information is on a white or lighter background, image extraction could take place. But when the background is dark, the image is inverted for better presentation. Lastly, the proposed feature is optical character recognition, which extracts image from all kinds of image. You just need to denote the path to the image. Rest the rotation and judging based on threshold if invert of the image will be a better choice or not is done in the program. Now, let's do hardware implementation with Raspberry Pi and Pi camera. Raspberry Pi is in its own way a standalone device, mimicking the mini computer capabilities. Thus we are using Raspberry Pi version 3 for our project, in which Pi camera module is attached. Hardware connections are as you will see in the demonstration after a few minutes. Resolution for our camera is 480 x 620 and with sufficient brightness level and contrast setting, this works well for vision of 5 meters. That is, in case of image captured, the characters can be resolved at standard size 20 printed on paper. With sizes above that, the distance can be made larger. And billboard case fonts can be identified from a distance of 40 meters. For hardware implementation we have used two major open source technologies. One, the OpenCV, which stands for Open Source Computer Vision Library. OpenCV Python makes use of NumPy, which is an optimized library for numerical operations with a MATLAB-style syntax. All the OpenCV array structures are converted to and from NumPy arrays. This also makes it easier to integrate with other libraries that use NumPy such as SciPy and Matplotlib. Every image is converted into array of numbers, which denotes the intensity levels between 0 to 255. This in our case is handled by the OpenCV. The second technology is Pi Tesseract, which is especially for Raspberry Pi. Tesseract recognizes and reads the text present in images. It can read all image types, PNG, JPEG, GIF, TIFF, BMP, etc. It is also widely used to process everything from scanned documents. Tesseract has Unicode UTF-8 support and can recognize more than 100 languages out of the box. In order to integrate Tesseract into Python code, we use Tesseract's API. The flowchart for PyTesseract is as you can see. It is handling all of our necessary processes. The main issue while using Raspberry Pi with OpenCV and PyTesseract when you are new to this kind of work is OS install Lion in Raspberry Pi. Then importing the library for OpenCV and using API of PyTesseract. Other references which you can check for the same are linked in the description box. Now we are at the demonstration of hardware implementation of the Optical Character Recognizer as our final year project. The system developed is robust and efficient, which gives strings of character when the program is run. The programs for reading a pre-stored file and file from the camera module are not provided. But if you are viewing this video and want to work on the same project, we can help you out. Reach us on any of the contacts mentioned below. We have 4 different cases. The first one is simple black and white image with text and numbers. Second one is a long paragraph, which has different text color and artistic font style. Third one is CAPTCHA code and it has colored background and character is also tilted. Fourth case is live captured image, which you will see in couple of moments. Let's see execution of these images one by one. After successfully extract text from pre-stored images. Now, check live captured image, that is our fourth case. Thank you to the learned faculty of Engineering College Rajkot for being selfless in imparting knowledge to us and pushing us further on this side of the field, where you can see you work in action. Thanks is also due to our guide and mentor we all look up to, Dr. C.H. Vithalani, whose zeal for technology makes us want to try something new, something different. Thanks to our image processing lecturer Dhawal Bhojani, whose ready knowledge about image processing and critical analysis helped us get through the challenges.